When most people think of power drills in general, they tend to think along the lines of something similar to this. This is a rigid 18-volt cordless power drill. It has, of course, a battery, has two sets of speeds, a torque selector, and a keyless chuck, which is sometimes hard to unscrew. But due to the recent innovations in the power tool industry, this in and of itself is a pretty old tool. And one of the things that people have really forgotten about are the older alternatives or the older styles of drills, mainly cordless drills and their various variations. Speaking along those lines, we happen to have 3 of those drills here today, and I'd just like to go over their features and kind of show how their operation works to kind of give people a better idea of how these tools operate. The first tool I'd like to focus on is going to be made by Ryobi, as seen here on the carrying case it came with. This drill is rather old. I do not know exactly when it was bought, but it has seen not very much use in all of its time, and it's a rather interesting drill in its design. As you can see, it immediately has a striking resemblance to your normal and typical cordless drill. Very interestingly, to just start off with the basic visual appearances, it has a keyless chuck. A very uncommon feature for most corded drills is that it has a torque selector, just like the cordless drill. So you can drive in fasteners, and you can see right here in the instruction manual is a 3/8 inch drill and clutch driver. So that's a feature that seems to be not very widespread and somewhat unique to this drill. We have a normal cordless drill styled direction selector and safety position in the middle, and then we see a feature more typical to corded drills, which is a trigger lock, which is not a very good thing to use. Most professional companies advocate against doing so. On the top here we have a level, which is another feature that seems to be more common in corded drills. And with that, that's pretty much it, aside from this slot here, which I'm not exactly sure what it is for. It's on both sides. With that, this drill, to go over its specifications, of course, due to the fact that it is corded, it is an AC drill using a universal motor. If we look at the builder's specifications here, see it's a 3/8 inch drill, 120 volts, and it is 4.5 amps, the motor in this drill. In the context of corded drill sized motors and various other things like that, it's a relatively small motor and relatively small power. However, it is still sufficient to get most jobs done. However, it may bog down in thicker pieces of wood when using very large twist drill bits. In comparison to this corded drill, it is slightly longer. It is, almost excluding the large cable here on the connector, it's almost as tall as the cordless drill. And just to give you a better idea of overall length from base end to base end, we can see that the chuck of the cordless drill ends essentially where the torque selector ends on the Ryobi drill. With that, it has pretty good cooling vents. As you can see, the rubber gripping textures all around here. Torque selector, it's pretty hard to twist, but it does work, and I have tested it, and I may show it here in the video later on when I power it on. But It is a working torque selector, and it seems to break on its lowest setting at a fairly low torque. So I cannot currently test exactly the measurement of that, but maybe at a later point it can be seen screwing in some screws or something like that. Now for this next segment of the video, I have the drill plugged in right here to a Kilowatt EZ, the more simplified model for those who do not know. And what we're going to do is we're going to measure the current of this drill, the current that this drill draws, and we'll see how it is unloaded. So to first start off the operation, or the differences of operation with corded drills, is the immediate way that their motors work and that they handle. With cordless drills, they are very quiet. And they tend to have linear triggers all the way up until around 2/3 the way. Where they go into full speed. Now, an immediate difference you'll notice with the corded drill is the fact that it hums due to it using a universal motor. These are all variable speed. Most drills nowadays are variable speed anyway. You can get some decent low speed operation, but the torque level of it, I don't know. You get better low speed operation on a cordless drill, which has a more circuit-based speed control system. But another thing is, sometimes when you pull the triggers very slowly on these drills and start them up, they'll kick, just like that. I don't know if you noticed, but the lights are dimming when I'm doing that. As you see, it did not do it that time, but let's see if we can get it to do it again. There you go. As for noise level, these things are moderately noisy. Some are noisier than others. This one's personally the quietest one I own. And one of the things is that you'll notice, very loud. Growls quite a bit, and that's just due to this thing being somewhat of a cheap drill. The motor's not held very tightly inside here, due to it just being held in place by being sandwiched between the split casing. So there's a little bit of vibration. But yeah. While I'm doing this, most people may assume that this drill is stalling out and trying to rotate. However, if we go ahead and look at the kilowatt, it's drawing around 6.9 watts. A feature of these drills is that as they speed up, they will draw exponentially more current. Let's see if we can go ahead and get both of these in the same shot here. I'll go ahead and go to full speed now. As you can see, pretty loud. There's a pretty good amount of current, and that was actually watts. Let's go ahead and measure amps. I'll just kick it into full speed for a second here. So around 2 amps unloaded. And with that, you can kind of see how loud this thing is. And in reverse, this drill, I think there's something a bit wonky with it, because if you'll notice, it sounds way different. It's more of a whine. compared to also, one thing that's not too good is that there's some decently bright, not very bright, but pretty noticeable arcing happening on the upper brush back in there. Let's see if you can see that. But yeah, as you see, I'm not too sure about the health of this drill. It hasn't been used very much. It's more just beat up from being left outside of its case for long periods of time. But yeah, that's pretty much all with this drill. I'm not going to demonstrate the trigger lock because it's just outrageously noisy. With the trigger lock, you also cannot determine the speed. It's just all the way on and lock it in. I'll go ahead and demonstrate it though. Again, with the drill off, you push it all the way in, lock it, and then you just click it once and it comes out. I'm not a big fan of trigger locks, but it's on this drill. Anyways, keyless chuck. Guess more to be like a cordless drill. Decently good. Unlike most cordless drills, it does have a portion for you to grab here on the bottom, because I do not believe it ratchets. Yeah, once you get it tight, but it's a shorter segment overall to grab compared to a cordless drill. So with that, we'll move on to our next drill. Now, to move on to our next subject of the video, we'll be moving on to this. One thing you might immediately notice is that the case is in weird proportions, and that is because this corded drill is actually a corded right-hand drill, again made by Rigid. One of the reasons why I have Rigid tools is because they have a lifetime warranty. Yeah, there are people who believe in other brands and stuff like that, but I like Rigid personally. One thing that you see immediately is that this is actually a combination tool. So the chuck regular drill attachment can come off, and it can accept multiple adapters, such as this kind of grinding wheel. It's not really a grinding wheel as it doesn't spin. It tends to vibrate back and forth. I don't know the name of it, but that is an attachment that I do have for this drill. Another wheel for that thing. But this is the next corded drill we're going to be talking about. And here it is. Obviously, yes, as I mentioned, right angle drill. And if we move the box out of here, you can get a better look at it. This drill is kind of interesting in its design. The chuck here is a normal, again, keyless chuck, but it is extremely short. It's a very condensed chuck, so there's not very much to grab onto. I do not believe that it has any ratcheting, similar to the Ryobi. Let's see right now. It's a very small capacity. I do not know the diameter of the chuck on this particular drill, but it's fairly small. As you can see, it's only about that big. But here it is. It has a external LED light there, and as I mentioned, the top can be removed. It takes multiple attachments. You depress these two tabs on either side, and the attachment will come off just like that. You can see the drive shaft of the drill in there, and to put it back on, you just line it up and put it back on. So with this being a right-hand drill, again, motor down here, the output axle or the chuck is rotated 90 degrees from the motor, so it's good for tight spaces. And you can see the back side of it. Interestingly enough, on this handle, you'll know it's non-symmetric, so it's almost more comfortable to hold it with your left hand as the end of your palm, the bottom side of your palm, fits into that groove right there, that depression in the handle. So it's almost more convenient to hold this with your left hand than with your right. Moving on to another thing about it, as you can see, the R and F. This drill has a speed selector, or sorry, not a speed selector, the reversible direction switch right below the long trigger for multiple of your fingers to rest on. Like most cordless drills, it does have a center lockout depression, and then you have forward and reverse. It has brush caps right here, something that you don't see very often, so you can easily replace and access the brushes. And if you go ahead and look on the specifications of this drill, this is only a 3 amp drill, so a little bit less capacity than the Ryobi, but you typically don't use drills like this for heavy-duty applications. And as you can see, obviously by its size, it is not a very heavy-duty drill. So to plug it in, move over to the kilowatt meter test. Got the cord. Go ahead and plug it in. And it's set to forward, and we'll go ahead and give this thing a whirl. And actually, when I said the Ryobi was the quietest, I forgot about how quiet this thing was. This thing is extremely quiet for an AC power tool. And if we set it down here, you can see the light in the front there. But one thing about this is this one, when I was referring to the kick when starting these drills at slow speeds, this one is typically the worst displayer of that. This thing does it very often, and sometimes the motor sounds very weird as you do it. That's another thing. It makes this kind of grinding, rattling noise at the lowest speed. It'll also do that. And then it'll do this sometimes. Let me see if I can let go of it to show you how much it kind of moves. There you go. It's very weird how it does this, but if you accelerate and then back off the trigger, it'll go back to working as normal. Again, to show you the max speed of this drill. No brake. It's quieter off the workbench. And the trigger is linear. It's just it's kind of sticky, so it almost works in increments only. And then we'll go ahead and go into reverse real quick, see if it's any different at all in reverse. More growling from the motor. That's a very interesting sound. I don't believe I've had this thing in reverse any other time than this video. The noise seems to go away as it runs faster. Yep. It's got that funky brush motor smell, so I think that's enough. It's not warm though, so yeah. Another reason why a lot of people don't like these AC tools is because when they overheat, they can sometimes fail catastrophically with a bunch of smoke and sometimes fire and stuff like that. But I don't see necessarily the issue with that, because as long as you turn it off when it starts smoking or when it starts getting hot, or don't let it bog down. That's not really an issue. So anyways, let's move over to the watt meter and see what kind of current we are getting out of this drill. Let's see if we can get in a spot where it's easily seen. There we go. So this is in the kind of messed up state. There we go. So now this is at our slowest possible speed, 0.6 amps. Let's go ahead and increase it. 0.5. It's going faster. We're at 1 amp, and let's hit it off all the way. So around 1.5 amps, so maybe a third of its maximum current rating. So overall, I will say the design of this drill is very weird. I'm not too much of a fan of it, but it works, it gets the job done. I've mainly used it with this attachment here though. I don't think I've actually used a chuck attachment. Right hand drills tend to be discounted a lot of times for some reason. Once upon a time, I was taking an HVAC class, and the instructor was demonstrating how to drill holes in studs for electrical work, or electrical conduit, and he was using a normal cordless drill like this, and he said due to the lack of space in between the two studs, when drilling the hole, you will need to do it at an angle in order to fit the drill bit into the hole. Well, later that same day, I found out that we actually had DeWalt cordless right-hand drills. As to why he did not want to use these drills or tell anyone about them is beyond me. I personally think right-hand drills have their own sets of uses. I think the only concern with them is if they get stuck, they can be real wrist breakers because the axis of the shaft is, it's pretty much a big L. So it'll twist your hand, but it's not like the same sort of twisting that you get with a cordless drill where it's like this. A lot of times when you're using cordless drill and it twists, it goes something like that. So that's not very common. It's much harder to do on a right-hand drill, but they're still not very commonly used for some reason. Now to move on to our largest, loudest, and highest in capacity drill, we're going to take a look at this rigid hammer drill. Now, one thing I have to say first off is that there are a lot of misconceptions as to what hammer drills are. A lot of people think a hammer drill is any drill that has a hammering function, but that is not true. A regular hammer drill is a normal drill like this, except it has a hammering function. A lot of people confuse what is called a rotary hammer, which is a drill pretty much built exclusively for hammer drilling that has its own proprietary system of bits that it uses. Anyways, this is a normal hammer drill. This is the box it comes in with its cord. As you can see, starting off, and actually to make a general statement, this drill has some very interesting features that you would not expect, very similar to the Ryobi drill. So let's go ahead and get it out of its box right here, or travel bag, whatever you want to call it, storage case. And we'll set it in the middle right here. So as you can obviously see, with this being a hammer drill, it comes with the additional hammer drill grip. Seen here, has the rigid logo on it. It has a depth gauge. That's what this rod is. You push this in and then move this rod here with the teeth on it, and that will control the depth of the drill when it is in the hammering mode. You just slip it onto this collar right here on the front and tighten the handle, and then the handle will be attached. You can put it any orientation you want, And that's that. I'm going to take this off for now and set it over to the side. So this drill here is probably the most conventionally designed in the context of staying in line with the design of most corded drills. As you can see, it has a trigger lock, and it has the more traditionally mounted reverse switch here, right above the trigger guard with no middle safety position. It's just forward and reverse. Again, very large trigger. It's a 2-fingered trigger, and it has this sort of swooping in design with almost like a grip here, so that you can slip a support hand over and grab it like that to put your pressure in line with the chuck and driving bit. And one thing you'll see here, this is very interesting. This is the only corded drill that has this feature, but this is a speed selector, just like the one on the cordless drill. What you do is you rotate this knob. One of the things that reminds me in our in that HVAC class, the safety section book, when discussing hammer drills, had this exact hammer drill as an image, and they marked this as an adjustment knob. An adjustment knob of what? Nothing, just adjustment knob. But this is actually a speed selector. What you do is you rotate it halfway, or kind of 2/3 the way. It doesn't rotate anymore. Then you move the chuck a little bit, and then it will go into the next speed setting. If that is how it is supposed to work, I have absolutely no idea, but it still works properly, and drill works fine. So yeah, it's very odd. You need to kind of line up the gears, I think, but that's how you do it. Now, this is a hammer drill, and the hammer drilling function is on the top here. What you do is you just slide this slider back and forth, and it will change between hammer drill and normal drill mode. On normal drill mode, as you can see, the chuck is locked from pretty much moving in any direction. However, on hammer drill mode, the chuck will move up and down, as you can see right there. And that's the impact effect of the hammer drill mode. So going back to this drill's operation, it's the only drill with corded drill with that speed selector. Very large, pretty heavy. We look here. I forgot about to say the model numbers. This is an R5011, 8.5 amps. So this is obviously the largest tool out of all of them. We have another universal motor running off of AC. And of course, as you can see on the front, you have a key chuck instead of a keyless chuck. The key is down here at the end of the plug. And the reason why that most of the time they're put down here at the end of the plug is so that you need to unplug the drill in order to take the drill bits out, so you don't have any accidents when swapping out drill bits. This key can be removed from this holder, and the holder can be moved around, but by default it's at the very end. So yes, again, it is a key chuck. You can rotate it like this by hand and then stick in any drill bits. I don't know if this is a masonry bit, but it doesn't really matter. And make sure it's centered in there. You tighten it, and then you use the chucky to get it very tight. I'll go ahead and close that up. And since there's not very much more to say on this drill, let's go ahead and plug it in and give it a run. Since this drill is the biggest, it is also, as you might assume, the loudest out of the three you've seen so far. But it has the most linear trigger I have experienced. As you can see, that's starting at at the lowest speed possible. Keep in mind that is on 1. And also you'll notice it doesn't kick very much. If we pick it up, it's very hard to do one-handed. But yeah, you see. Anyways, if we want to switch the speed settings, we can go ahead and do that. And we see it moves. At a much faster rate of speed. So, going into the forward and reverse. As you can obviously see, one direction is more powerful than the other. If you look at our kilowatt over here, go and take a look at the reading. Just at the slowest speed, we see it already draws 1 amp, which is pretty funny. Full speed on this drill, ridiculously loud. I think I'll only do that one time, just for the kilowatt. I'll just go ahead and show you the variable speeds, kind of like this, but I won't go full speed, so. This thing has a lot of mass, so it's not necessarily, you can't really get away with screwing in fasteners and things like that with this. It's just not going to happen. So anyways, here it goes. We're going to practically turn on a siren with this thing because we're going to go at full speed. So here we go. We'll just go ahead and get it done with. Make sure you can see it so you don't have to redo this. Alright, here we go. So yeah, as you guys can see, super loud. Surprisingly, it only drew about 2 amps. The current kind of steadily increased before it plateaued off. Just for funsies, I guess we'll go ahead and try it in reverse and see how it goes. That's why you want to unplug it. Interestingly enough, if you look in there, let's see if we can capture that. Yep, a little bit of sparking. See if it's warm. No. So, brush health, I'm not too sure about it on all these drills. I guess most universal motors, I'll just put put the handle on real quick. I guess most universal motors, when you operate them at their full speed, they kind of produce some sparking in there. But especially with these drills, it seems to happen more when they're run in reverse, or maybe it's just because you can't see it when they're being run forward. But it's another thing with these drills I'm not too sure about necessarily how much sparking they should make. This drill I know has not been used very much. It's been used maybe once or twice, and it's only been used in the hammer drill function. I use this one for pretty much about everything because I knew practically nothing about these, but just happened to have them. So in the future, I'll probably end up using these guys a little bit more. And yeah, that's just a basic overview of these corded drills.